number 6. All right, so quadratics number 6. In this unit, there's a ton of different lessons, and a lot of them cycle back through different skills. This one's going to cycle back through factoring, and even when I was thinking about the last time we covered this, I didn't cover it very well, so it's perfect that we cover it again. The question says, when factoring quadratics, we ask about multiplication and addition, and that produces the result we need to form a standardized process. So the first example is x squared minus 14x plus 45. X squared minus 14x plus 45. And just some background information. This says factoring polynomials is the subtitle. So factoring polynomials. And let me try to maybe warm you up a little bit, right? Let me warm you back up to math. What's an operation in math? What is give me an example of one operation in math. Multiplication. True. True. So if multiplication is an operation in math, for other people sitting in the room, give me another operation in math. Addition. Good. You see how your brains work? One spark. And then all the sparks start sparking, right? Who's got another one? What's another operation in math? Keep going. What is it? Yes, subtraction. What else? I think you're missing one of the sort of big 4. Division. Did we say that one? Okay. And what you've got is a forward and reverse. You've got an operation and its opposite. And we go through these all the time, and I think it's a good way to warm up. It's a good way for your brain to get back into math, right? You know a lot about math. You've covered so much math in your life. You've forgotten a lot more math probably than you realize, okay? So this thing called operations, right? So you got operations, strange words. I don't know where we get them, but that's it. So you said add slash the reverse of it. I'm just going to write sub, right? Because that's what we taught you. We taught you addition first, and then right after that, we taught you subtraction. And what it is a forward, right? You're walking forward with addition. And then with subtraction, you're walking backwards. And I always try to point out to you that which is more difficult, walking forward or walking backward? The backward is always a little bit harder. You can't see where you're going, right? You trip a little or whatever. Does this make sense? And then we taught you, what was the next one we taught? Mult. And div, if we stay on track. Then I try to go for high school where we push you up even higher. What's this next one I try to push for? Do you know the next one up? What is it? Good. Good, good, good. And you mentioned the reverse first. Root is the reverse. What's the forward of root? Again, strange words, right? Root. I mean, what the heck? What's the forward of root? Okay, so I'm going to tell you. It's power. Power slash root. Those are forward and backwards, right? This is raising to a power. To reverse it, you have to take a 2 root of a 2 power, and then it goes back to just an x. Does that make sense? Forward and reverse. Then I'm going to try to push you further and add another one to the list. And this one is sort of not a pure forward and reverse, or not a pure operation, I guess. It's actually a modification of multiplication and division. So this one is distribute or distributive property slash factor. Okay, so as you get up into these, your brain is very familiar with these. You know all about add and subtract and multiply and divide, but power and root, less familiar to you, and definitely distribute and factor, less familiar to you. So distribute is a form of multiplication. If you had 5 times x plus 3, distribute means to distribute the 5 across the terms in the parentheses. This would be 5x plus 15. And that's what happened to produce this, by the way. If you remember what produced this, why it's called a quadratic, what had to happen for this trinomial to be produced. Do you remember that? Maybe, and I'm not asking that question very clearly. Do you remember what we had to do? What created this? It was a process of distribution that created it. Do you remember this? Give me something. What created it? How many steps created this? Yeah, good. So, and we don't hear you, but we see you. So 4 multiplication steps, right? And what it is a variation on distribution. It was 2 binomials, right? X, this is not going to be the factoring of this one because I want to factor that one. So let's make one up. X plus 3 times x plus 5, right? When we multiply 2 binomials, it produced 4, the FOIL method, it produced 4 multiplication steps, which gave us this trinomial because we combined like terms for the minus 14x. Okay, so that's kind of a long-winded warm-up, but the opposite of distribute is to factor, to go in reverse. So now when somebody says to us, factor this polynomial, they want us to go backward and produce the 2 binomials that were multiplied to get to this, right? So this is a variation of division, and it's called factoring. And these are all sort of in your toolbox of your operations in math. All right, fair enough. So let's go through the process. Let's say to ourselves, there's 2 things happening that produce this. One was multiplication. Give me factors of 45. See this positive 45? Factors. Remember what factors are? Factors are what 2 things multiplied together could produce this 45, right? Give me an option. What times what can equal positive 45? 5 times 9. Everybody agree? And what happens in these problems is we like to also see it in reverse up, switched, especially if we had that lead term. And this unit in quadratics sort of goes a little bit more difficult, then it backs up to simpler, then it goes back into difficult again. So these lessons are kind of this back and forth method. All right, this is back to a little simpler because we don't have that lead term here. If we did, we would want to write this 9 times 5 also. We would want to write 5 times 9 and 9 times 5. Okay, those are 2 factors of positive 45. Fair enough? What's another set of factors?
1 times 45.
Yeah, 1 times 45. Don't forget that one. That's an oldie but a goodie. A lot of times your brain forgets the easiest ones. Somehow they're not as easy, I guess. Okay, so whatever it is. So these are both factors. These things multiply to equal 45. The next question you have to ask is, let me see how I draw it on the notes. Which pair of these did I write my problem right? Ah, interesting. Which pair of these adds to now equal this middle term? All right. So she went down to the nurse's office this morning. As far as I know, she's there now, but I do not know. Okay, all right. Sorry for the interruption. So I want you to now switch modes. We multiplied to get this. Now I want to add and subtract to get this, right? And in this case, add. So now take these 2 factors and add them. What's 5 plus 9? 14. All right? I like 14 because it matches 14. What's the problem with this 14 though? It's negative. Is there a way for me to adjust these 2 factors to make this negative? I need 2 factors of 45, positive 45, and then I need them to combine or add to be a negative 14. I got a positive 14 here.
Well, if it's a -5 or a -9, it still turns into 45.
Very good. If it's a -5, times a negative 9. Isn't a negative times a negative a positive? And isn't 5 times 9 45? So this is a set of factors we didn't consider yet. So it's okay to forget. You don't have to do a complete list of factors when you run through multiplying what multiplies to equal to 45. But if we make a mistake and we can't figure it out, and this is a positive 45 with this one, what we really need is this one here. When you add negative 5 and negative 19, now you've got a negative 14, and that matches the middle term. So the two factors we're interested in here are these here, the negative 5 and the negative 9. And when we set up our two binomials, because we know this was produced by two binomials, we've got an x and an x, and we have a negative 5 and a negative 9. Notice how much more complicated the factoring process is going backwards, right? Or division in this case, a method of division to get back to this. A lot more difficult. And let's prove it. Let's check it by doing FOIL quickly. What's FOIL stand for? Bingo. All right. So x times x, x squared. Outside negative 9 times x, negative 9x. Inside negative 5 times x, negative 5x. Last, negative 5 times negative 9. Negative times negative is positive, and a 45. Do you see the problem emerging as we go through FOIL again? Combine like terms. Negative 9x, negative 5x, negative 14x in the middle term, plus 45 on the tail, I call it, and this x squared up front. And that's checked because that's where we started. Right? So all you're doing is applying an operation, in this case, a distribute process, and then a factoring process. We're going back and forth between them. We're simply walking forward to get to one thing and walking backward to get to another. The simplest version of that would be, here's your add and subtract. What's 5 plus 3? 8, right? How do you get backwards? You take 8 minus 3, back to 5. Some variation of that forward and reverse. Now we're just doing it a little bit more complicated in terms of you're dealing with x's and binomials and trinomials and those things, right? So I think we can do one more. And I don't really like this method, but let's do it because it's in the notes. This is another version, and there are quite a few versions, by the way, of factoring. There's the diamond method. How many were taught the diamond method of factoring at some point? Okay. So this is an X method, and then a matrix is attached to it. And I think it's way too complicated. I'd rather go through this process, but this can get a little messy for students, and they don't like it either, right? So they're like, okay, show me something different. First things first, you need to know A, B, and C. A, B, and C. In this problem, what's A? Close. Let me ask you this. What's B? Good. B equals negative 14. With that said, go back and look at what A is. What? Yes.
Oh, you're right. Yeah.
It's so easy. It's really, really hard, okay? It's really, really difficult for your brain to see the invisible 1 up there. It doesn't, because here's the generic. A, x squared, that's the generic formula, plus B, x plus C. So B is the number, the coefficient as you call it, with the sign, so that makes sense. A is the coefficient with the sign, got to be a positive 1. What is C now? Okay. So we need for this method A, B, and C, and you need it for several different things as we go through. So it's fine to go back and just go, what's A, B, and C, and practice that a little bit. Then this method gives you this A times, this is B, and A times C. Oh, I did a different problem in the notes, you guys. All right, fine. We'll do this. A times C, right? This is kind of overkill for this one. I did a one with a coefficient in the notes. I'm sorry, I just got started rolling down with the same one we were doing. What's A times C here? A is 1, we said. C is 45, so we got 45 here. What's B? We already mapped it out. It's negative 14. Now it comes back to what two numbers multiplied together add up to equal that negative 14. And we know it now because we've solved it. But if we went through this before, we would put something like a negative 5 here and a negative 9 here, because when you multiply them, we get this number. And when you add them, you get this number. So now we've got everything mapped out. The matrix starts to ask yourself, well, let's put the x squared here, and let's put the 45 here. And now it's just a matter of mapping out what goes where. Well, if I multiply an x by an x, I get this x squared. And if I put in the negative 5 up here, and the negative 9 here, I don't know whether to draw my negative vertically or horizontally. Now it looks like a plus. X minus 9, right? So these two together, if you took a minus 9 and a minus 45 and multiplied them here, if you came across this way and said minus 5 times the x, you'd get minus 5x here. If you did the x times the minus 9, you'd get minus 9x here. And this gives you the basis of, see the x minus 9 as one of your binomials. And you see the x minus 5 as one of your other binomials. Anyway, it asks us to review this again. And I think you should play with it. You should try to write this out and see if you can mimic it and put things where. On the notes, it shows you AC here, that's a setup. B is a setup here. Now, this you have to know what two numbers multiply to be this and add to be this. Then it starts to do things like tell you to put in, the x squared goes here. The 45 goes here. What else they show you in the notes? There's arrows everywhere, drawn everywhere. Wow. And that's about it. So I think you should practice that one, just for the fun of it. Especially if you're headed toward a math major, go back and practice it. And there's problems in there for you to practice with, and there's solutions in the Schoology video that's in there. And, oh, I did 2 problems like that. FOIL is 4 multiplication steps which produce a quadratic. First, outside, inside, last. Binomial is 2 terms. A trinomial is 3 terms. And I was going to say something else, but I forget. Oh, go back and do, if you're finished with the assignment for this week and the notes, please go back and do the IXL. They walk you through in a lot simpler steps, a lot of these different steps to help you through it.